Special data types. And here we have special data types. The OpenJS geometry model, we have supported special data format, geometry, well, formness, and validity, special reference system support, creating special columns, populating special columns, fetching special data, optimizing special analysis, creating special indices, and finally using special indexes. So here we have the Open Geospatial Consortium. The OGC is an international consortium of more than 250 companies, agencies, and universities participating in the development of publicly available conceptual solutions that can be useful with all kinds of applications that manage spatial data. The Open Geospatial Consortium publishes the OpenGIS implementation standard for geographic information simple feature access. You have the part 2 and SQL option, a document that proposes several conceptual ways for extending an SQL RDBMS to support spatial data. This specification is available from the OGC website, and this is the link. Following the OGC specification, MySQL implements spatial extensions as a subset of the SQL with geometry types environment. This term refers to an SQL environment that has been extended with a set of geometry types. A geometry value SQL column is implemented as a column that has a geometry type. The specification describes a set of SQL geometry types as well as functions of those types to create and analyze geometry values. MySQL spatial extensions enables the generation, storage, and analysis of geographic features, data types for representing spatial values, functions for manipulating spatial values, spatial indexing for improved access times to spatial columns. The spatial data types and functions are available for MyASM, INO database, NDB, and archive tables. For indexing spatial columns, MyASM and INO database support both spatial and non-spatial indexes. The other storage engines support non-spatial indexes as described in section 13.1.15. Create index statement. A geographic feature is anything in the world that has a location. A feature can be an entity, for example, a mountain, a pond, a city, a space, for example, town, district, the tropics. A definable location, for example, a crossroad, a particular place where two streets intersect. Some documents use the term geospatial feature to refer to a geographic features. Geometry is another word that denotes a geographic feature. Originally, the word geometry meant measurement of the earth. Another meaning comes from cartography, referring to the geometric features that cartographers use to map the world. The discussion here considers these terms synonymous. Geographic feature, geospatial feature, and geometry. The term most commonly used is geometry, defined as a point or an aggregate of points representing anything in the world that has a location. The following material covers these topics: the spatial data types implemented in MySQL model, the basis of the spatial extensions and the OpenJS geometry model, data formats for representing spatial data, how to use spatial data in MySQL, use of indexing for spatial data, MySQL differences from the OpenJS specification. For more information about functions that operate on the spatial data, you can check out the section 12.16 spatial analysis functions and additional resources. You have all this stuff. And now we're gonna move to the next section, that is gonna be, let me see, we're gonna have the spatial data type, and here we're gonna see some examples. So MySQL has spatial data types that correspond to OpenJS classes. The basis for these types is described in section 11.4.2, the OpenJS geometry model. Some spatial data types hold single geometry values: geometry, point, line, string, polygon. Geometry can store geometry values of any type. The other single value types, point, line, string, and polygon, restrict their values to a particular geometry type. The other spatial type data types hold collections of values: multi-point, multi line string, and multi-polygon. Geometry collection. Geometry collection can store a collection of objects of any type. The other collection types, multi-point, multi-line string, and multi-polygon, restrict collection members to those having a particular geometry type. Example, to create a table named geom that has a column named g that can store values of any geometry type, use this statement, and this is what we are gonna do. So we are gonna log in with our credentials. I'm gonna go into my Windows PowerShell, and I'm gonna type in MySQL-u root-p like this, and then it's gonna prompt me for my password. Okay, so it let me in, and now we're gonna create table geom, and inside of the parentheses we have lowercase letter g and geometry. So we have columns with a spatial data type can have a srid or srid attribute to explicitly indicate spatial reference system. So spatial reference system SRS for values stored in the column. For example, we have this, so let's try it out. And here we're gonna type in create like this, and it's gonna be, we're gonna create a table. But first of all, we need to, okay, so let me see, show databases like that, and we are gonna use the common queries database. So we're gonna use this database, and now let's show tables. So let's see, we have table T. Okay, so now we can create a table geom like that, and we're gonna open parentheses, and to the next line we're gonna type in lowercase letter p, and then it's gonna be an uppercase letter point, and it's gonna be srid. So srid like that, and we're gonna have 0 here, okay, comma to separate it, and we're gonna move to the next line. It's gonna be lowercase letter g, and this time it's gonna be geometry like this, and it's gonna be not null, and it's gonna be srid or just srid, and the number is gonna be 4326. And then we're gonna close, and we're gonna go to the next line, close it with the parentheses, close the parentheses, and end it up with a semicolon. Okay, so query okay, 0 rows affected. So we have that. Spatial indexes can be created on spatial columns if they are not null and have a specific srid. So if you plan on to index the column, declare it with the not null and srid attribute. So let me see, we have the create table geom. So let me see, show tables, and now we have the geom table. So in this case you will have the lowercase letter g, geometry, and here we have not null srid, and the number would be 4326, the one that we already have here. Eno database, Eno databases tables permit the srid values for Cartesian and geographic SRSS. MyAscent tables permit srid values for the Cartesian SRS. The srid attribute makes a special column for the srid restricted, which has these implications. The column can contain only values with the given srid. Attempts to insert values with a different srid produce an error. The optimizer can use spatial indexes on the column. You can check out the section 8.3.3 spatial index optimization. And finally, the spatial columns with no srid attribute are not srid restricted and accept values with any srid. However, the optimizer cannot use spatial indexes on them until the column definition is modified to include an srid attribute, which may require the column contents first to be modified so that all values have the same srid. For other examples showing how to use spatial data types in MySQL, you can check out the section 11.4.6, creating spatial columns. For more information about spatial reference systems, you can check out the section 11.4.5, spatial reference system support. So we have that for the section, the spatial data types. So let's check out the next section. It's gonna be really short, and it's pretty much the OpenJS geometry model. So inside of that, this is the content. We have the geometry class hierarchy. We have the geometry class, point class, curve class, line string class, surface class, polygon class, geometry collection class, multi-point class, multi-curve class, multi-line string class, multi-surface class, and multi-polygon class. The set of geometry types proposed by the OGC's SQL with geometry types environment is based on the OpenJS geometry model. In this model, each geometric object has the following general properties. It is associated with a spatial reference system, which describes the coordinates space in which the object is defined. It belongs to some geometry class. So that's what we have for the OpenJS geometry model.